Oh boy. So here's the Nist update, the 29th. What is this? Concrete truck? Well, it's only got one wheel there and two in the back. Wait a minute. What's this? What's that? Ball peen hammer. Ball peen hammer. Being swung up by probably a human hand, so that changes the variable. What are these? Steel pipes? All right, this is ground vibration sensing testing equipment. I'll get to it for you. And it's inside the CTS structure playground. All right. What you see here is a mound. All right. Dampeners are what I want you to think of. Dampeners. Dampener. This truck was borrowed from, I don't know, one of those two states they borrowed it from. Each tire is different. Take note of the tires. This is a repaired tire, no longer the same as that. And therefore, they will not engage the soil, and behavior will not be the same. The tires, this vehicle passes vibration through the truck, through the tires, into the ground. This is like children playing scientists with each other to stroke. What I mean by that is, oh yeah, I like your idea. Hold on, you know, it's a circle jerk is what I'm trying to say. Stroking each other off, telling each other, oh, you're doing great. Oh, I like it. Yeah, you do it. You get that. Yeah, that's $2 million, right? You'll get published and you'll get a better job. You know, you'll publish. You worked with NIST on this investigation. Yeah, let's see the reports where they talk about the testing the equipment to confirm that it's playing fair. All right. So they drove steel pipes down to the ground. They state such that compresses the soil as you go down, and oh gosh, it changes the dynamics of the impact of the vibration. Not only that, they're testing. Let's do this. Let me just give you a profile, right? So let's just do the slab. All right, here's the slab. Oh boy, this is so annoying. And then here are, let's do the pure cap. Hell, let's start over. Let's make a pure cap. All right, here's the pile caps. All right, depending where they are, there are 3 of them configured as such, so they look like sort of like this. 1, 2, 3, and then here's your pile. Your pier. All right, your pier goes on top. It supports. This is the one that comes out of the ground here, right? It's got the deck on top, the pool deck, parking garage. But these are the piles, and this is the pile cap. All right. The load transfers not so much, but somewhat on surface tension a little bit, but more so on its ability to stop. I think this was 50 tons each. 50 tons each on these, so it's 150 tons. Now they're going, they obviously the results came back that, well, apparently the results came back that, wow, this thing didn't really fail. It didn't really fail. You know what? Let's go about it differently. Let's check the soil. Let me do a different color. And let's go with black. Let's check the soil all around it and see what kind of frequency we can get the soil to behave like. It doesn't matter. It had a concrete pad. This is at the floor level there. It had a concrete pad. Concrete pad. Then we have our pure cap, pile cap, our piles. 1, 2, 3. Let's call that 150 tons. Some of them had a lot more than this. Some of them had 9 groups of 9, so you do the math. But out there in the pool deck area, I think it's about average like 150 tons. That shape I showed you, like that. 1, 2, and 3, and then the center line would be your pile. I mean your pier. So they're checking the soil out here along the side. They're checking all this soil with this what you see here in the background here, these things. They want to see what kind of frequency it will take. For what? To what end? To where? to where they're going to do some extrapolations that is totally false. Because here's your pipe into the ground here. And here's multiple pipes. 1, 2, 3. It's in line here. Well, they remove part of this concrete cover. That changes the dynamic of the behavior of the concrete. The evaporation of the moisture in here changes because it's surface air now, will change the frequency of it. The air pressure will change the frequency of it. Wait a minute, I said air pressure? Right. So underneath this truck, the air pressure is going to be different than out here with your vibration. If you don't think so, climb under there when this thing starts shaking and feel your ears friggin' come to life. All right? That it's an air pressure. The frequency creates an air pressure too when they're dealing with these frequencies like this. And, well, I'm creating an air pressure when I speak to you even. But the soil, so let's just say they use, this is test probe 1, here's test probe 2. And probe wire, a reading over here. This one gives a reading here. And they go, oh, this one, they bang on a hammer here. This is a hammer. This reading also gives a reading of, say, a value of 10. They go over to this one, and let's say that gives a value of 9. This one gives a value of 9. All right, so it transfers pretty nicely through there. And then the next one gives a value of 8. Okay, starting to fade out. Fade out. But here's the thing. This is a frequency truck that doesn't exist. There was no frequency in the garage like this. If they were going to mimic behaviors in thinking about the sheet piling, for example, they do nothing else besides get a truck out there, same truck, grab the sheet piles, and drive them down there and see what you come up with. Drive them out there in that walkway. They're the government, the federal government, so they got access to do it. Go down that roadway. It's in Miami, and driving down a sheet pile. It's far enough away from the building. Of course, they should be doing what? They should be doing what here? They should be insuring the buildings next to them, because they get ready to do a vibration test, right? And they claim that the vibration can knock down a building. Well, clearly they should be worried about the knocking down buildings with their vibration test. It's never been done over here. They don't know how it's going to behave. Clearly, driving a sheet pile in every 2 feet of sheet piling every few minutes, and with pauses between it, can take down an entire building 3 years later. Clearly, this truck should not be called what they call it, something like Monstersaur, some childish name. That it should clearly be insured for hundreds of millions of dollars, $1 billion, to do this test. This is slaps in the face of the whole failure thing, saying vibration did it. Their vibration testing, clearly there's a wall there still exists. The walls are on the outside of the structure. They can go take measurements off those walls to see if their vibration shake vehicle what it will do over there. Again, it doesn't matter, because it was not this way. It was not this way. This soil over here has never experienced the vibration that they're putting on it. I would say never. No one's ever put a truck like that down there at that location, cut with concrete on top of it, do a trench like that, drive pipes into the ground, and then with sensors, and then start a vibration machine, a truck over top of it, stationary, and try to extrapolate. The soil has never seen that before. The soil will consolidate. It will consolidate. Initially, this area here will consolidate first, and then if it can consolidate the rest of these materials, it will. But remember, you only have, if I start trying to consolidate these stones up here, and I vibrate, they're going to vibrate apart. But the soil may, if you figure out the right frequency, you can get it so it starts drawing in, and then too much, and you'll get it to push away. But doing so, you now make a break. You make more from around this vibration. You're now making more voids. A negative effect is pushing away at that point. I've been saving this for a while. I didn't know that they would make it so easy. I've been wanting somebody to debate with me about vibration and why it drops off. You're consolidating. You're trying to transfer it through materials that are soil. And that's what's going to happen there. The soil is going to vibrate different frequencies, and it'll consolidate, or push or vibrate or push away even. But you're not going to just put a vibration on that soil and it goes, okay, all soil stay where it is. I'm going to touch you and you pass it off to the next grain of soil next to you. And then you pass it off. Now, there'll be some consolidation going on. And we also have other issues here. There's another vehicle in the background. This is a dampener. The rubber tire dampeners. This whole mound is a dampener. This is a joke. I mean, this is their test. You know, even if you base it off this, well, it doesn't matter what you impact at. 10 pounds of, you just can't measure this like that. It should be a slide drop measurement. You pick up so many inches, you release. That's the way it should be. It should be like a slide drop. So this is a 10-pound weight. Right here, you slide up the bars. You measure from here to the top of your metal. You have indicators here to see if your metal's going to also drop down. So you're going to use gauges here to see if you're up 2 sides at least. Maybe 4, but if you know, it depends on how critical you are. And you're going to drop this weight down, this 10-pound weight. It will impact the top, and it will be reproducible. You'll see that if your gauges, if your indicator shows that the pipe is driving into the ground, which is going to change, of course, change your dynamics. You have this wire here, dampener again. And they're just loosely laid here and here and here. These are all dampeners. The mud flaps, interesting. They're not touching the ground. They would change the frequency back there with the pressure as a ricochet shield, a blast shield. So this states that this is over here in September 29, 2022. Update Champlain Towers self-investigation. Complete site testing. Announces next advisory committee meeting. Okay, soon to come. Yeah, whatever. The summary. Let's see. Thanks, Charles, for your links. There's the public meeting. Okay, so they got access. They came up with some other idea. They were like, oh, wait a minute. We need to test this further. And they borrowed some equipment from, thanks to Army Corps Engineer, National, whatever. Let me see the town. Where is it? They borrowed a mobile shaker right here. Utah, Texas. Okay. The National Foundation, National Hazard Engineering Research Infrastructure at the University of Texas, in collaboration with researchers at Utah State University, contributed a specialized truck designed to shake the ground at specific frequencies, nicknamed the Thumper. So it can shake all at once, but it's going to shake the ground at specific frequencies. Where do they measure that from? It's on 4 tires. They drove it there. The behavior is going to be all different. And where do they measure that frequency? Do they measure it on the surface? And then say, okay, the truck is now putting out, 90 hertz, let's say. 90 hertz. All right, this tire over here, do they measure that side? That one's 80 hertz. All right, the matter, the frame, and everything's a little different. This is 80 hertz, 90 hertz. Okay, what do you do with this data? In the front tire, putting down pressure at, say, 60 hertz, and maybe this can bounce around a little bit. It's got a little bounce to it, and that's 75 hertz. All right, let's call it 85 hertz. It's bouncing, it's dribbling, and the vibration, the ground sensors, the transducers are picking up these numbers. I mean, all right, so this zone, how far? Then now you have to move your transducer to figure out what's its influence. Where does it drop off to 0? That's just your surface now. Now you'd have to profile your pipe into the ground, going, okay, I'm right going through the ground, 6 inches here, and above us here is 85 hertz. Here's the tire. Okay, it's 85 hertz. I push down 6 inches. I'm still at 85 hertz. Give it another inch. You go down another inch. You're like, oh shit, just dropped off. It's 50 hertz. You're like, oh, okay. So you're profiling your pipe. Well, what's it doing over here on the transducer on the surface up there? It's still 85 over here. It's still 85. All right, or whatever. It drops off 75. So then you go down to what? Where are they getting these readings from? Obviously, there's only one wire going in. Apparently, one wire going in. It could be multiple leads. But I just don't think they have the technology to do this. I don't think this is the technology, unless you're just trying to corrupt, just trying to come up with global warming. World Economic Forum said this is going to be global warming. Remember? I did a video on that. They've already decided it. They're part of the federal government. The federal government, WHO, all part of the same agenda, electric car type deal. All right? So, and NIST is not above lying about like N95s used for suppression of the C word. Don't trust me. Look it up. N95s are designed for a salt medium, a dust. Is the C word, is that a dust medium? Oh, it's not actually, is it? And you got a certain breathability that you have, breathing rate you have to do, pressure, and humans just don't do that. You know, it takes training to use that mask properly, and that was with the dust, and that's the salt medium. It's the wrong mask. NIST recommended the wrong mask. I trolled them on it. They deleted the content a few times for that. Then they deleted my ass off of YouTube, Twitter on that one. But I had a couple of channels up, so no harm, no foul until they find the other channel, and I could care less. That's why I said it to you guys. So if somebody's hating on me, go complain. Go complain. The best thing you can do is get me kicked off Twitter. I don't, just less of this stuff I got to deal with. You'd be doing me a solid. All right, so after viewing for my haters, I mean, just telling you how you can try to go after me. I'm throwing myself under the bus for you. Just do it. We were able to leverage incredible resources and expertise through our interagency agreements, and so incredible. I find it incredible too that you think this is good data. The technology we use has been developed and applied primarily for earthquake research. Okay. So a building failure investigation is a novel application. So they're just trying to, remember I showed you the fire department playing around up there trying the jackhammers. Try this with the jackhammer. Same thing here. This has now become, hey, try this. All that. Yeah, let's see what we can get for that. Try this. It's free money. We can use the 22 million up. Yeah, do that. Yeah. Okay. And geotechnical engineering. Shout out to Charles. We're able to bring together multiple types of cutting-edge technologies to better comprehend the ground behavior at different depths. It doesn't matter, because what matters is that it's got to come up through a pier, right? To get to the structure. And to get through that pier, it also has to go through a pile cap, and then piles. 50, 50, 50. If you want to know what's going on here to see, so you're vibrating the soil around here, means nothing unless it moves this system. Whether it be through rotation, through settlement, even heave if you like. But, so you were talking about expert archaeologists in this case. An archaeologist would be the one hey, look, I think this elevation's changed. Or, you know, maybe a real geotechnical engineer with some brain power in him, where he says, let's do some core samples. Let's drill this down. Let's open up the core. Let's look at it. Let's look at it for density. Let's actually check it like we would in an oven and things like that. Old school. Not this new school, we're going to find a shortcut to do it. We're just going to add a little vibration, and then we're going to call it a day. We don't even have to do that core sample. That long core sample, that there be a waste. You could plug the shit out of this. You could put holes everywhere here to figure out what this soil is doing. You could plug down here and get to the bottom of this literally and see what it's doing. You could load test this, as I told you. It says 150. Figure out the real load of that decking, apply it on top, and let it sit there. They have plenty of time to let it sit there. So let it sit there for 10 days if you want. See if you get any creep, any settlement, even though it was exposed to water, and that changes the dynamic. Remember, this has been over a year exposed to water, saturating the soil below. You're going to get a different soil dynamic than if you protected the site and tested it then. Even the core samples now are shit because you waited too long. You waited over a year. The thing flooded and water was sat on it, and you know they made holes to allow water to go through. And now all of a sudden, after they destroyed the subsurface with all this water and access, they're now saying, let's test the subsurface. Yeah, you're testing it after you flooded it many times, after you dropped a building on it, after you had excavating machines with vibrations on them, cleaning, brooms, another machine they use for doing that sample over there, power driving, right? So, pile driving. So you did all that. You changed the dynamics of the soil below. And now you're like, ooh, let's test it. Yeah, you're just testing what the fuck you damaged. You can't write this stuff, guys. This is the National Institute of Science we're talking about, right? This is NIST. This is the National Institute of Science and Technology, and they don't have the brain amongst them all with all their PhDs, and I'm not hating. I just, I'm just using it to triangulate high. With all their PhDs, masters, skill sets, education, teachers, etc., they're like, oh, let's test it. And nobody's coming forward and saying, yo, you know what? That test is kind of moot now. It's the car's been wrecked. They rebuilt the car. They welded a frame and all. It's not going to be the same car anymore. It's not the same anymore. We got holes everywhere. We got a vehicle out here. We got a mound over here. And, we got pressure. We got an environment that doesn't even exist anyway. So, right here, the team used custom-built vibration sensors and pushed them into the ground to measure wave propagation. Did you see the machine called? Let's see what the machine's called. If it's right here, I missed it. The team was used custom-built sensors. Okay, used custom-built vibration sensors, custom-built, and pushed them into the ground to measure wave propagation. So custom-built. So it might have a cone on it, all right? So it's compressing the soil as it goes through. All this will be compressed around because it's got to displace it. So this will be tighter soil here, just a little bit gradation, and tighter soil like this. And then they're going to tap it and get vibration. Remember, so the soil's tight. It's going to behave differently than the soil that was undisturbed. If there's any undisturbed soil there at all at this point. Okay, the team used custom-built vibration sensors and pushed them into the ground, right? With a unique configuration of sensors that formed a square, the researchers were able to visualize how the waves travel through the site's subsurface soils relatively short distances and determine soil caster. So again, relatively short distances. So, let's do the pattern like this. Well, let's see. Let's see the truck. So tire. We know it's straddling. So, I mean, you see the layout there. We saw it straddling, and they said square. And so, well, what the hell? I don't see it. I don't see the other, the square pattern. The other car's to the right. To the left is a mound. So, what do they consider square is the question. Square pattern. Square wave. I see a lot of rocks falling back over there. Look like they're consolidating on like a angle of repose. I mean, square wave. What's square? What's their definition of square? Okay. The data can help investigators determine how the structure may have interacted with the soil and foundation. Well, it didn't interact with the soil and foundation. It interacted with this system here. Pile cap, piles, and some surface tension, skin friction, and the buck 50 over there with that. And then the other one underneath the garage is even greater. That's what you want to look at. 150, sorry. That's what you want to look at. And they're out here saying, I wonder how the pad was resting on, how the pad was reacting with the soil below. It doesn't matter. It had rebar all on that mat. The pad he's standing on now, this guy's standing on. Rebar's all there. It's very similar to the deck above. So you want to look at the cracks there. It'd be nice. But they're not smart enough for that. Okay, let's read. The team includes experts from Georgia Institute of Technology, created high-resolution 3D images of the section's foundation piles. Long columns of concrete and steel. Oh, they're just saying, they're trying to describe to you what a... the 3D images of sections of foundation piles. So they're saying that these are the foundation piles, maybe? Which would be very interesting. That means they pulled the one out. They were extracted from the site by the civil litigation experts. Okay, so remember we saw them down there? Let's go from there. So we scroll up, and you see what shape are they? What are they? What's their shape? They're kind of like this. So why are they kind of flat here and like this? Well, they probably drilled when they did this piling. Hold the wait for it. When they did the piling, they drilled. Wait for it. And then when they pulled the round drill bit out, some of the soil collapsed back. And then nobody went down there to fix it, obviously. And then they just poured into the hole and you get this deformed shape. All right. Not true. Okay, not true. They used pressure-induced piles. They were a couple of ways. They drove it and they used pressure-induced piles. They were prefabbed, driven into the ground, as I understand, and then, of course, cut the heads off. The rebar sticks up, and then you engage a pile cap on top. I'd like to see what that is. I think I did find that one. So here it is saying Nist, all right, is there, and they're using whatever, I don't know, targets of some type. There's 3D mapping of it that they're going to then put out somewhere. I'd love to see where that came from, because it's very short, and it got up to 150 already. Remember, I talked about it in another video. I said, look, when you drive this one, this is going to be the one that's going to go in the easiest, but it consolidated the soil around it. So when you drive this might be a little tougher. And then the last one will be even more tough because the soil here was tightened up. That's considering that they're not acting as individuals. Noteworthy would be to pull the ones you're concerned with, just take them out. The building's not going to recycle them. The new building owner's not going to recycle them. They got $20+ million for this deal. Pull them the hell out. So pull them out. So and then investigate it properly. You know, look at it. Look at the subsurface down there. Look at the depth. See if they're all at the same depth. Were all of these, 20 feet? Was this one 23 feet? This one became 50 tons at 20 feet. And this one became 20.9 feet. 20 feet, 9 inches. Check that out. Look at the profile of them. Let's go. But the new owner might even let them have it. Might still let them get at it. Have at it. Okay. In addition to the efforts of the collapse site, the team completed an inventory of specimens collected. This is the new specimen collector guy right here. Engineer out of Florida, I think. All right. He works for them. To ensure the chain of custody was preserved, the transfer of those specimens were formally documented. An independent consultant employed by the civil litigants. Materials have been preserved in a secure location, Miami-Dade County, under 24-hour surveillance, where they have been carefully measured and cataloged. So that would mean locked door and a camera. NIST has begun the careful extraction of core samples of some of the evidence so that it can be laboratory analyzed. This is all smoke and mirrors, guys. Smoke and mirrors. Smoke and mirrors. Instead of looking at the deck, and they're looking for the magical bird, because the revenue, tax revenue. They can't have taxes going down. They can't have people running for the hills. They can't people have running for the hills. I simply state These are bridges. All these things with cars on top of them, driving there, parking, driving off, partying, whatever it is, it's a bridge. What's a bridge do? Transport a car across it, transport vehicles across. This transports vehicle across. This bridge you're allowed to park on and throw parties on, obviously, and things like that. And actually, you're allowed to put another wear layer on that's friggin' huge. You can do what you want to on this bridge, and you don't have to have it separate from the building. So if you simply have these bridges sheared from the buildings, all right, sheared from the buildings at whatever cost. Now, if the bridge collapses, you don't get the building collapse with it. They should have 2-year inspections, just like they do with bridges, and it should be, answer to the municipality and the civic association, the people that own the units. So you've got to have it so your building doesn't, so it can shear away if you get a bridge collapse. And expansion joints, control joints, expansion joints, construction joints, where it will separate from the building, separate from pads, maybe sectional failures as opposed to these huge slab failures. So what we have here, isn't that amazing? They have something called wet land deep core sampling. What would that be for? In case you want to build on that location, they want to take a core sample. They'll go through the ground, put a little 2-inch, a little pipe in the ground, and then vibrate the topsoil and go, yeah, you know what you can do here? You can build a 14-story building. These are really, guys, it's not the way it's done. That shit's they're just being lazy. They think they're trying to do a shortcut on analysis. Requires the core sampling, multiple places to explore what's under there. You don't know what's under there. That little vibration thing is not an indicator of if a 14-story building would be able to withstand XXX. All right? This is what it looks like. They come apart. This is one, they open them up even. Some of them open up. But this one is like that. And you can look into them and say this was the monkey rock area zone. You know what I'm talking about, evolution. This was the fish area where fish were discovered. This is where the 2 rocks did the naughty. Oh no, that would be down here. 2 rocks banging bang. Or I like playing around with that part of me. Hold on. And ultimately, you get this long core sample, right? You dig down again if you want, but you start getting a profile of the surface. You go, oh, there's more clay here. Oh, as we go down, it's silt. Oh, what the hell? It's sitting on top of a layer of dirt. Oh, look at that. There was a water vein. Oh, keep going through the water vein was only 3 feet. Oh, below that, it's got to be supported by something. We're back to soil. You take this up, you test these samples, and now you can talk about the behavior. They got $20 million. They can do the proper way. Not this, I'm going to put a probe into the ground this deep and vibrate it, and you're only going to get you're only going to get data from this area here, maybe a little bit down here. But they're going to try to claim that this area here can fall a building. It more likely could. That's why you don't build on it. You don't build on it. They didn't even build their pad on it. They put reinforcement in that pad. They didn't trust that sand, soft area for even a car loading. So this is unfair. This is a sneaky way of putting fake data out there and pulling the wool over you sheep who might believe this crap. I'm ending the video. I'm triggered. Love you. Bye.